collinearity is something that we covered in the straight line topic. So if you can remember, you had to find the gradient of two separate lines, and if they shared a common point, it made them collinear. So it's very, very similar for vectors. Rather than finding the gradient, you're going to find components, but we're still going to have a common vector. So if we start off by finding A to B, remember A to B is B minus A. So that's 6, 3, 6 minus 3, 2, 4. Remember, work your way down, x is down to z is taken away. So 6 take away 3 is 3, 3 take away 2 is 1, 6 take away 4 is 2. So the components of AB are 3, 1, 2. We're now going to work out BC. So to find BC, we do C minus B. C is 12, 5, 10, and we're going to take away 6, 3, 6, which is B. 12 take away 6 gives us 6. 5 take away 3 gives us 2, 10 take away 6 gives us 4. And that's the components of BC. Now, similar to with your straight line, you don't have to choose the points A, B and BC. You could have done AB and AC. You could have done a variety of different things, as long as you use at least one point in both of them, which obviously you're going to end up having to do anyway. So now we need to compare these. If you look at the vector AB and compare it to BC, what you should be seeing is that the vector BC is twice the vector AB. So if we multiplied all the components in the vector AB, we would get to the vector BC. So AB times it by 2 gets us to BC. So this would mean that our lines are parallel. So BC equals 2AB. Therefore, so remember little dots for therefore, vectors are parallel, and since B is a common point, A, B and C are collinear. Now remember, you have to make that statement, so you have to understand how you do it, but you also have to give an interpretation of what you've done. What does it mean when we've got to the point where one of them is multiplied by something to make the other? So this next example is very, very similar. However, this time we're given a little bit more information about our component vectors. So we know the point A, we know the components of A to B, and we're getting told that A to C is 3 times A to B. And they want us to find C. So this time we're actually working backwards to find one of the points. Okay, so instead of being given the 3 points, we're now finding one of the 3 points. So I'm going to start off, if we know that A to C is 3A to B, that means that it's 3, 2, 0, 3. So that was given to me in the question. So A to C must be equal to 6, 0, 9. So just multiplying through by 3. Remember, to get A to C, you would have to do C minus A. So C minus A must be 6, 0, 9. And we were given the components of A. So C minus 2, 5, 4 must be equal to 6, 0, 9. Now, you can just solve that straight off from there to find C, or if you wanted to, you could continue it as an equation. So we are saying that C must be equal to 6, 0, 9 plus 2, 5, 4. So C must have components 8, 5, 13. Be careful with the wording of the question. We tend to use components. We work through with components when we're doing vectors questions, but this question specifically asking you for the coordinates of C. So C has the coordinates 8, 5, 13. And that's my final answer.